tried in solving FE exam for civil engineers. Today I will solve, or I will go through several fluid mechanics and hydraulics questions. So let me first share my screen. Okay. So question number one, the continuity equation in fluid mechanics is based on which conservation law? Now we all know the continuity equation, it's a mass balance. So it's based on conservation of mass. So the answer is B. It is not conservation of energy. It's not conservation of momentum, and also it does not have to do with angular momentum. So the correct answer is B, which is conservation of mass. Now the second question, Reynolds number is used to predict the flow regime. Which of the following Reynolds number values typically indicates laminar flow in laminar and pipe flow? Now, pipe flow is classified as laminar flow or turbulent flow based on Reynolds number. Now, the classification is if Reynolds number is less than 2000, then the flow is laminar. If the Reynolds number is more than 4000, the flow is turbulent. Now, if the laminar Reynolds number is between 2000 and 4000, the flow is in a transition state. So among the choices here, C represents laminar flow because the Reynolds number is less than 2000. Question number 3. Which instrument measures fluid velocity by converting dynamic pressure into static pressure? Now there are several choices: orifice plate, venturimeter, pitot tube, and flow nozzle. Let's look at these different devices, measurement. All these devices, they measure flow in pipes. So this is an orifice plate. The first one is an orifice plate. So in the orifice plate, there's an orifice, a plate where there's an orifice placed in the pipe. Now at the orifice, at the location of the orifice, as we see, because the diameter of flow decreases, so the velocity increases. And if we apply Reynolds number upstream somewhere when the diameter is full, is complete, and somewhere at the orifice, we see that to conserve the P over gamma plus Z plus V square over 2G. Now as the velocity drops at section 2 at the throat or at the orifice, as the velocity as the area decreases, the velocity increases, which increases the kinetic energy, which increases the kinetic energy. So for the energy to remain constant, the pressure at the orifice will drop. So by knowing this, the pressure drop, we can determine the flow or the velocity of the flow. So in this tool or in this device, the pressure energy upstream is converted to kinetic energy downstream. So this one does not convert pressure energy into static pressure. So this is not the answer. Now the other two devices, again the venturimeter and the nozzle flow, the nozzle, they are similar in principle. They are similar to the orifice plate. So all of these three devices, they convert pressure upstream, pressure energy into kinetic energy, and that causes a pressure drop. Now, the only tool or device that converts pressure energy into static energy is the pitot tube. Now, the principle of the pitot tube is that there is a stagnation point here at the entrance to the tube, which, because the flow is stagnant, then the pressure goes up, the hydrostatic pressure goes up. So this device, the principle of this device is based on converting the pressure upstream, the pressure energy upstream, to static pressure at the tube, at the stagnation tube. So the answer is the pitot tube. Just answer C. The next question. What is the primary effect of increasing fluid viscosity on the Reynolds number in a given flow scenario? Now, in Reynolds number, the definition of Reynolds number, you see the equation, which is rho v d divided by mu, where mu is the dynamic viscosity, v is flow velocity, d is pipe diameter, and rho is fluid density. So here, by increasing fluid viscosity, the dynamic viscosity of the fluid, that makes or reduces Reynolds number. From the equation, we see that if mu is increased, then Reynolds number will decrease. So the answer is B, decreases the Reynolds number. Next question. Which equation is used to calculate head loss due to friction in pipes? Now, head loss in pipes is calculated by this is the head loss in pipe, which is the friction coefficient, L over D, V square over 2G, where L is the pipe length, D is the diameter of the pipe, V is the flow velocity, and G is the gravity acceleration, and F is the friction coefficient. This equation is known as Darcy-Weisbach equation. So the answer is B. Now, the Bernoulli equation is used for energy conservation. Continuity equation is for mass balance, and energy equation is again for energy balance. Now, the next question, in open channel flow, Mann's equation is primarily used to estimate which parameter. Now, Mann's equation is used to determine, we all know that Mann's equation is used to determine flow in open channel, flow velocity in open channel. This is Mann's equation. V equals 1.49 over NR to the 2/3 is to the 1/2, where V is the flow velocity, N is the friction coefficient, and R is the hydraulic radius, and S is the channel slope. This is a very well-known equation used for determining flow velocity in open channel. So the answer is B. The next question, what does the fluid number represent in open channel flow analysis? Now, in open channel, fluid number is used to classify flow. Now, this is the formula for fluid number. Fluid number equals the velocity divided by square root of GD, where D is the hydraulic depth, defined as area, cross-sectional area, divided by the throughput, the T, and G is the gravity acceleration, and V is the flow velocity. So this definition is inertial forces. Fluid number V represents inertia. So fluid number represents inertial forces divided by gravity forces. So the answer is A. It is not ratio. There is no viscosity in the fluid number. We say there's no viscosity, so B is not an answer. C is also not an answer. Ratio of pressure, there's no pressure. And D, the ratio of gravitational forces to viscous forces. Again, there are no viscous forces, so also D is not an answer. So the correct answer is A, inertia forces to gravitational forces. The next question, which description best characterizes turbulent flow in a fluid system? Now, in pipe flow, we know that the flow can be either laminar or turbulent. Now, laminar flow is characterized by very well organized flow, and the water flows in layers, and there is no mixing between the layers, as we see in the first pipe. Now, turbulent flow is characterized by turbulence, and there is mixing between the fluid layers in the pipe. So choice A, flow with uniform parallel layers. So this is not turbulent flow. Choice B, flow exhibiting random chaotic fluctuation, which is the correct answer. C, flow is completely dominated by viscous effects. This is not correct. Now, I will show you now which flow is dominated by viscous, correct, by viscous effect. The flow occurs only in small diameter. This is also not correct. So the correct answer is B, flow exhibiting random chaotic fluctuation. Now, these two figures show the velocity profile. The first one is the velocity profile in laminar flow, and the second one is the velocity profile in turbulent flow. We see that the velocity gradient in the laminar flow is much higher than the velocity gradient in the turbulent flow. We see that the turbulent flow and the velocity across the section is almost uniform, and that causes in laminar flow viscous effects become important. We know that viscous forces or shear forces depends on the velocity gradient. So in laminar flow, viscous effects become important, and in turbulent flow, viscous effects are not important. Pipe friction is more important than viscous effects when we talk about head loss. So head loss in laminar flow is mainly caused by viscosity, and in turbulent flow is mainly caused by pipe friction. This is important, also an important distinction between laminar and turbulent flow. The next question, in a venturi meter, the pressure difference between the converging section and the throat is used to calculate the fluid flow rate. Which physical principle is primarily applied? Now, how do we determine, now in the venturi meter, this is a venturi meter. Now in the venturi meter, it is used to determine the flow velocity, and how to determine flow velocity, we apply Bernoulli equation. So we apply Bernoulli equation at the upstream section where the cross section is full, and at the throat. You apply Bernoulli equation between section 1 and section 2 at the throat. Then from Bernoulli equation, we can find a formula to calculate the flow velocity, and consequently the flow based on the head loss, based on the pressure head difference. Question number 10, so the answer is D, Bernoulli principle. Now the next question, which dimensionless number is primarily used to characterize the onset of turbulence in a fluid flow? Now, we talked about laminar and turbulent flow. So in pipe flow, Reynolds number is used to define or to classify the flow into laminar and turbulent. The answer is A. Now, Froude number is used for open channel, and Mach and Prandtl, these are different numbers. So the answer is A. The next question, in open channel, what does Mann's coefficient minus roughness coefficient represent? The channel slope, the slope of the channel bed. Now, Man's coefficient represent, it is a frictional coefficient. So the cross-sectional, the slope, not correct. B, the cross-sectional area, not correct, of course. Flow density, not correct. The effect of channel surface roughness on flow resistance. So the answer is D, the effect of channel roughness on flow resistance. So the answer is D. This is the Man's friction coefficient or channel roughness. The next question, which equation is used to quantify energy losses due to friction in a closed conduit? Now, in a closed conduit, the head loss or the frictional losses are determined by Darcy-Weisbach equation, which is head loss equals the friction factor by L over D, the length of the pipe, divided by the diameter, divided by the diameter, B square over 2G. So the Darcy-Weisbach equation is used to calculate or quantify head loss in pipe flow. The next question, which is the significance of the term hydraulic radius in open channel? Now, we saw in Bernoulli in Man's equation, there is a term hydraulic radius. This is Bernoulli. This is Man's equation. So this is the fluid number equation. Yeah, this is Man's equation. So this is the Man's equation. V equals 1.49 over N R to the 2/3 S to the 1/2, where R is the hydraulic radius. Now, the definition of the hydraulic radius is the area, the cross-sectional area divided by the weighted parameter. So this is the definition of the hydraulic radius. So we go back to our question. So the hydraulic radius is the ratio of flow area to the weighted parameter. So the answer is A. It is the ratio of the flow area to the weighted parameter. Next question, which parameter is used to determine whether a flow is subcritical or supercritical in open channel? Now, open channel is classified, open channel flow is classified as either subcritical or supercritical, and the classification is based on Froude number, which we just seen. This is the Froude number, V over square root GD. So if the Froude number is greater than 1, so the flow is supercritical. If the Froude number is less than 1, flow is subcritical. Now, supercritical flow is characterized by high flow velocity, shallow high flow velocity. It has high kinetic energy and low potential energy, while subcritical flow is deep and slow. Subcritical flow has high potential energy and low kinetic energy. So this is how you can sometimes distinguish between subcritical and supercritical by just looking at the flow. So when the Froude number is greater than 1, flow is supercritical. When the Froude number is less than 1, flow is subcritical. When Froude number equals to 1, flow is critical. So this is how flow is characterized in open channel. So the answer to the question is B, Froude number. Now, question number 15. In the study of fluid mechanics, what does the term laminar describe? We talked about laminar and turbulent flow. So laminar flow is flow that occurs only flow with smooth parallel layers, which is D. Flow with smooth parallel layers. We said that in laminar flow, fluid or water flows in layers, and there is no mixing, lateral mixing between the layers. Each layer flows smoothly. While turbulent flow, there is mixing between the layers. So the answer is D, flow with a smooth parallel layers. Next question, which term describes the pressure energy per unit weight of a fluid in a system? Now, pressure energy, velocity head, no, velocity head does not represent the pressure. Elevation represent elevation or potential energy. Pressure head, so pressure head is the correct answer. Because the question pressure, so the answer is pressure also. Friction head is not the answer also. Now, in Bernoulli equation, it has three terms. One term represents potential energy per unit weight, which is the Z term, and V square over 2G represent kinetic energy per unit weight, which is V square over 2G, and P over gamma, which is a pressure head, represent pressure energy per unit weight. So the answer to this question is C, pressure head. The next question, in fluid dynamics, what does the term compressible flow refer to? Now, compressible flow and incompressible flow is defined as when we measure that by d rho by dp. How does fluid density changes with the pressure? If a fluid density does not change with pressure, with increasing pressure, so we call the flow is incompressible. Now, if a fluid density changes with the pressure, so the flow is compressible. Usually, airflow is compressible flow. Air is compressible fluid. Water is usually incompressible for most of applications. Now, water becomes compressible in transient flows, which occurs at when unusually high pressure occurs because of pump failure or because of sudden pipe closure. So water flow in pipes is incompressible. So which is compressible? So flow where density variations are negligible, flow where various viscous effects are dominant, no. Flow where changes in density are significant. Yes, so flow where changes in density are significant is compressible flow. So the answer is C. Next question, when measuring fluid flow in a channel using a weir, which principle is primarily applied to relate water depth to flow rate? Now, in open channel, in open channel, we apply energy Bernoulli equation. So in weirs, when we use weir to determine flow in a channel, we apply Bernoulli equation. Conservation of momentum, we apply conservation of momentum, but for when we talk about momentum, we talk about forces. So conservation of momentum, not the correct answer. So hydraulic jump, not also the hydraulic jump. Hydraulic jump is different. Empirical weir equation when measuring flow in a channel using a weir, which principle primarily applied to relate water depth to flow. So we usually use Bernoulli equation to derive the weir equation. So the answer is A. 19, which effect does an increase in the roughness of a pipe interior surface have on friction factor in turbulent flow. Now, it decreases the friction factor, increase the roughness of a pipe in turbulent flow, decreases friction factor. No, it has no effect on the friction factor. Also, this is not correct. It increases the friction factor. So the answer is C. It increases the friction factor, and also D is not correct. Now, in turbulent and laminar flow. Now the head loss in turbulent or in laminar flow is dominated by viscous forces. So it's a function if the flow is laminar, Reynolds number is less than 2000, head loss is a function of Reynolds friction factor is a function of Reynolds number only. It's not a function of the pipe roughness. Now, in turbulent flow, in highly turbulent flow, when Reynolds number becomes too high, we see, if you look at these curves, the emoji diagram, the curve become straight, so that the friction factor is independent of the Reynolds number. It becomes only a function in the pipe roughness. So at completely turbulent flow, the friction factor is a function in pipe roughness. So increasing the friction factor of the pipe does increase the friction or the head loss. The next question. In Darcy-Weisbach equation, which parameter primarily represent frictional losses in pipe flow? Again, this is about head loss in Darcy-Weisbach equation in pipe flow. So Darcy-Weisbach equation is used to solve or to determine head loss in pipe flow. So the which parameter primarily represent the frictional losses. All these factors, the length, the diameter, the velocity, they affect the frictional losses or the head loss. Now, the head loss, now frictional losses are represented by the friction factor or the friction coefficients, which is F. So the answer is C. Now, which of the following, the next question, which of the following is an assumption when deriving Bernoulli equation? Now, Bernoulli equation is applicable to steady, incompressible, inviscid flow. So the flow should be steady, it should be incompressible, and it should be inviscid. So which of the following is an assumption? Fluid is compressible? No. Flow is steady? Yes. So flow should be steady. Viscous forces are predominant? No. And the fluid density increases with the pressure? No. So flow should be steady. This is an assumption for Bernoulli equation. So this question concludes this video. If you have any questions or any comments about the questions we went through in this video, please send me or write to me in the comments. If you have any question you need help with, please also send me in the comments. Yeah, so I will see you in the next video. Thank you, and I will see you in the next video.